working principle or working mechanism of the rotahelper. Before going to demonstrate the working mechanism of the rotahelper, first we should know what is rotahelper. Rotahelper is the most efficient, fastest and environment-friendly equipment which is used to remove the volatile solvent from a non-volatile sample. It is a modern equipment in the chemistry laboratory. It was first discovered by Lyman C. Press and it was first commercialized by Buki Company in 1957. Now we are going to introduce the principle of the rotahelper. The principle of the rotahelper is that it increases the rate of the evaporation of the solvent by basis of three principles. One, first, reducing the pressure in the evaporating system to reduce the boiling point of the solvent, and increasing the rotation of the evaporating flux to increasing the surface area and heating the solvent. Now we are going to introduce each part of the rotahelper. First, here there is a motor mechanism which rotate the evaporating flux, and this axis is called evaporating axis, which is vacuum type to draw off the solvent from the sample. This part is called vacuum system, which is used to reduce the pressure in evaporating system to reduce the boiling point of the solvent. And this is called condenser, which is used to condense the vapor solvent coming from the evaporating flux, and it is joined by a cooling machine also called chiller, which is filled by cooling solvent like acetone or water. Here we use 50% ethylene glycol or water. And this part is called water bath, which is used to heat the solvent, that is, which is present in the evaporating flux. And this is the receiving flux, where we receive the evaporating solvent, that is condensate, and after condensation we get the distilled solvent which is present in the evaporating flux. And there is also a motor mechanism which is used to quickly lift up or lift down the evaporating flux. Now I am going to concentrate one plain extract. This was the methanolic plain extract of last year's Spinoza plant. First we join the expanding adapter size is 24, but the size of the RB mouth is 29, which matches with then the evaporating axis. First we join the evaporating flux which contain the sample. Then we go to set the pressure. For methanol, according to Buki manual, we set the pressure at 340 millibar. Then we click OK button. Then we click the Start button. Now the pressure is attained near about 340 millibar. Then we can rotate the evaporating flux. First we put it down to the water bath, then we start the rotation. we should careful the water bath should be filled with distilled water, not otherwise tap water. If we use tap water, then it may be the chance of rusting of the water bath. We know that the boiling point of the methanol is 64.4 degrees Celsius, but here we maintain the boiling point is near about 40 degrees Celsius because here we use the mechanism of reduced pressure to reduce the boiling point of the solvent which may be evaporated, or the temperature of the chiller is maintained is near about -7 degrees Celsius. And this is the difference between the Rota vapor and the simple distillation technique. For simple distillation technique, we set the temperature at 60 degrees Celsius for methanol because boiling point of the methanol is 64.6 degrees Celsius. But in case of Rota vapor, we set the temperature at 40 degrees Celsius because due to the reduced pressure. This is the advantage of Rota vapor, that we can evaporate the solvent less than its boiling point. This is the whole mechanism of the Rota vapor. Now the process will continue until the whole solvent present in the evaporating flask first evaporated, then condensed, and then it is transformed to liquid form and we collect in the receiving flask after redistilled. And almost all the solvent evaporated and condensed, then it is transformed to liquid form and we collect here the redistilled methanol. First we stop the rotation, then lift the evaporating flask to the water bath, then we release the pressure. Here we hit the stop button. After attaining the pressure near about 1000 millibar, we discharge the evaporating flask from the system. Now this is the desired concentrated extract of Lassa spinosa.